Welcome to CSEGuru. In this session, we will discuss the second topic under computer system organization, that is storage structure. There are two types of storage we are going to discuss here. One is about the main memory and another one is secondary memory. And main memory is considered as the primary storage for the program execution, and it is also called RAM, random access memory. And this main memory will be implemented in a semiconductor technology called dynamic random access memory, that is called DRAM. Generally, whenever we want to execute any program in the sense, the CPU will automatically load its instructions to the main memory for execution. That is, when the program wants to be executed in the sense, its data and instruction should be in the main memory. Then only all other devices can able to access it, so that the data and instructions will be accessed and executed quick. So typical instruction execution cycle follows an architecture called von Neumann architecture. This is a well-known architecture. What is von Neumann architecture in the sense? The CPU will fetch the instructions from memory and store it with the instruction register. These registers will be built along with the CPU in order to access the data and instructions fast. So, whenever CPU wants to execute any program in the sense, the corresponding data and instructions will be fetched from memory and store it with the instruction register. Then decode the instruction and fetch the operands required from memory and store it with the internal registers. After decoding, execute the instruction. After execution, store back the result. We will get the result after execution, right? So after execution, store back the result in memory again, so that it will be used for other program or process. So here, if you are considering in this sense, memory unit will be considered as a stream of memory addresses. So this is nothing but von Neumann architecture. So simple meaning is, whenever we want to execute any task in this sense, the corresponding instructions, data and instructions will be stored with the registers, that is in main memory, so that it can be able to access it very quick. Okay, after execution, we will get the result. That result also we will update back with the memory. This is the simple concept of von Neumann architecture. So we may think, all the data and instructions, why not we will store with the main memory permanently? But that is not possible for two reasons. The main memory is too small to accommodate all the data and instructions, whatever it is executing. Whatever the program CPU executes, all the data and instructions, it is not possible to store with the main memory because it is too small. And also it is volatile in nature. What do you mean by volatile and non-volatile memory? Volatile memory in the sense, once the power is switched off, the data will be erased. We will lose the data. Okay, till the power is on, data will be retained. Once power is switched off in the sense, we will lose the data. Non-volatile in the sense, if you are switching off the power also, the data will reside in the memory. That is non-volatile memory. Okay, so the main memory, because of these two reasons, we cannot able to store data and instructions permanently with the main memory. Okay, because it is too small and volatile in nature. So we need another type of memory, that is called secondary storage or secondary memory. That is an extension of the main memory. So the main advantage of secondary storage is, it can able to hold large quantities of data permanently. And the most common secondary storage device is nothing but magnetic disk, which can able to store both program and data. And the storage structure we are going to discuss next. And the storage structure will consist of registers, main memory, magnetic disk is only of many possible storage system. And other storages include cache memory, CD-ROM, magnetic tapes and so on. So the main differences among various storage structure lies in the speed of accessing data and instruction, cost, size and volatility. So based on that, we have different categories of storage devices. So this is the hierarchy of storage devices. And if you are considering this hierarchy, at the top is registers, then cache memory, then main memory, then solid state disk, and then magnetic disk, optical disk, and then comes the magnetic tape. And if you are considering this hierarchy from bottom to top, if you are considering in this sense, the devices will be expensive. So bottom, if you are considering in the sense, it is less expensive compared to registers. Registers are more expensive devices. Okay, so it is expensive and fast access. Compared to registers, magnetic tapes are slower to access it. Okay, So registers are faster in accessing data and programs. So that during execution, the data and instructions will be stored with the internal registers. That is the reason. Okay. So registers are more expensive, then the cache memory is expensive, then main memory, then solid state disk, then magnetic disk, then optical disk, and then magnetic tape. But registers are faster in access. Next comes the cache memory. Next comes the main memory, faster in access. So likewise, the hierarchy goes. So expensive and faster in access from bottom to top. And next, if you are considering in the sense from top to bottom, if you are considering in the sense these storage devices cost will be decreased. So registers are expensive. Okay, and here cost will be decreased for magnetic tape. Decreased cost per bit, and also access time is high. From bottom to top, if you are considering in the sense, the memories are expensive and fast. From top to bottom, decreased cost per bit and access time is high. And it requires more access time. Okay. And then if you are considering in the sense, the first four memory, that is register, cache memory, main memory, and the solid state disk. If you are considering in the sense, the first four memory are semiconductor memory. And then the register, cache memory, and main memory, if you are considering in the sense, that is volatile in nature. And the remaining four memories, if you are considering in the sense, solid state disk, magnetic disk, optical disk, and magnetic tape, if you are considering in the sense, they are non-volatile in nature. So what do you mean by volatile in the sense? Once the power is switched off for these devices, registers, cache memory, and main memory, once the power is switched off in the sense, the data will be erased. Okay, data will be lost. But in solid state disk, magnetic disk, optical disk, and magnetic tape, the data will reside permanently. Even when you are switching off the system also, even when it is not in use also, data will be stored until the user is erasing the data or deleting the data. Okay. And the data stored in non-volatile devices are safe for keeping. Okay, we can able to keep the data for long time permanently. Okay, and the solid state disk are generally faster than the magnetic disk and are non-volatile. And here the most common secondary storage device is nothing but the magnetic disk, which provides storage for both program as well as data. And most of the programs, if you are considering in the sense, they will be stored in the disk only until they are loaded into the memory. And many programs, they use the disk as both source and destination of their processing. So here, proper management of disk storage is the central importance to computer system, because it only handles data and instructions for execution. Okay. Considering here, the solid state disk have several variants, but in general are faster than the magnetic disk and are non-volatile. And one form of solid state disk is large DRAM, which stores the data for normal operation, but also have a hidden magnetic hard disk and a battery for backup power. If external power is interrupted in the sense, this solid state disk controller copies the data from RAM to the magnetic disk. When power is restored in the sense, the controller will copy back the data into RAM. And another form of solid state disk is flash memory, which is popular in cameras and PDAs, personal digital assistants, and in robots. And this will help for increasing storage on general purpose computers. And flash memory, if you are considering in the sense, it is slower than DRAM but needs no power to retain its contents. And another form of non-volatile storage is NVRAM. This is another variant of non-volatile storage. This is a DRAM with battery backup power. Here memory is fast as like DRAM, and here memory is non-volatile. Generally, if you want to improve the performance of these storage devices in the sense, we can install caches in order to access and transfer the data fast between two components. So this is all about the storage devices. Thank you for watching this video.